This is the diagram for that one. So let me show you the sketch. You can use this one here. Okay. Some of the nomenclature you can understand. The the helical length, it is the length. This is like a DC. Okay. So if I draw it like this, this is the axial length. Okay. Axial length is, for example, like DL, small length. Okay. This is the angle theta. Suppose this is my screw and the channel. So the channel is, the barrel is over here. So this is the height of the channel, and this is the width for a small, for a single, I would say, two spiral um, grooves. But you can unwrap it. Unwrap it, it will look like the same rectangular strip. So at an angle theta. So I'm this is my axial. This is, sorry, this is my helical length. We call it D, the small part. Okay, if you take it. So if I draw a line here, what is DL? This is DC. You will see what is, okay. If this is the angle here, if this is the angle here, suppose this is, let me redraw it here. This is the angle. Okay, let's redraw it here. DZ. Let me clearly redraw it here. If I draw it, this is my, suppose this is my screw. Okay, and this is the angle with the vertical line, and this is my DZ. This is my straight line. This is my DZ, and this is my straight line DL. So DL over DZ would be equal to sine theta, and we need to find DL is the axial length. This is the axis, along the axis, and what will happen to DZ would be equal to DL over sine theta. Okay, now I want to show you the, after you understand this part, the helix velocity. What I mean by that, that if this is a barrel, okay, so the screw has these two grooves, okay. So you can tell me, Professor, this is the tangential velocity of the barrel. The barrel is spinning like this. Actually, this is not the barrel, but we assume the barrel is spinning. We actually, the screw is spinning, but the spinning, if you make the screw stationary, then the barrel is spinning. So it doesn't matter much. So if this is V Z along the Z axis, this is my Z axis, okay, Z axis, and this is my X axis. So this is my X axis. This should be perpendicular to this one. Vx. So Vz if you drop a perpendicular here, so VZ, if I write down what is my VZ, so you will tell me VZ over VB, which is cosine theta, right? This is a right angle, so this is my V barrel. If you drop a perpendicular over here with this theta, so this velocity is along the helix line. This is the VZ. So VZ is over here. This is the velocity, which is also known as the velocity to push the pellets forward. And Vx, that component, the barrel which is rotating, it is also uh, doing the velocity in this direction, which is also known as a pumping. Let me show you the actual terminology in our case here. Sorry, pumping is the Vz. This is stirring. This is Vz is our pumping velocity, and this is known as stirring. It is the the spinning action of the screw creates two types of velocity on the pellet. One is keeps on moving the pellets towards the die. One it keeps on stirring. So Vx is the components. This is another diagram to show you how the process looks like. So there is a derivation process, flow in the round die or the runner. Let's come to the final formula, which is more important. This is just the derivation. So if you have a round die, there is a process, derivation process. So let me show you the final formula here. dP over dz is for the screw side. This is on the screw side, and this is on the die side. The shear stress for the Newtonian fluids, it is the formula, shear stress equals to viscosity times du over dr. And then we have another formula here, the strain rate, which is du over dr, can be written like this. Still not the complete, yes. So this is the formula for the flow inside the die. Please write down this formula. When you have a rectangular die, make sure it's a rectangular die, then you will use this formula, the flow inside the rectangular die. There, I will show you two cases, one for the rectangular die, the other one for the cylindrical die. And in the extrusion process, the material, the polymer is injected through a die. And as I mentioned, the flow rate coming out of the screw is equal to the entering into the die. And similarly, pressure inside the screw is equal to the pressure drop in the die. So let's do one problem. So you need to know a few things here. So let's do one problem here. extrude a polymer through a die. Please note down this data. So the cube, if I ask you, okay, this is the extrude a polymer through a die. So this is a screw side. Okay, the screw side is here. This is the barrel, and once it pushes forward through the die into the mold, this is our mold cavity or a die which has a mold inside. Okay, now what will happen? This is a die. This is our die, and it is a mold cavity with the dimension. So the mold has a dimension cylindrical. So if I draw a cylinder, what is the area? The diameter of the cylinder is equal to 5 millimeter, and the length of the cylinder and the velocity, injection velocity, is 10 centimeter per second. So now I want you to find out what is the Q product. P stands for the product. You will tell me, Professor, it is the area times the velocity. The velocity is 10 centimeter. So area is, what is the area? Pi d square over 4 times the velocity is 10 centimeters. So 1 meter. 10 centimeters equal to 1 meter. So diameter would be, let's write down diameter, 5 into 10 to the power negative 3. So let me write down here pi 0.005 square divided by 4 times 1. And if you do the math, this is equal to 1.96 into 10 to the power negative 6 meter cubes per second. This our the flow. Polymer is flowing inside the mold rectangular die. What happened? It's showing. Okay, now let's go to the next slide. It has given us some data. Polymer density is given, viscosity is given, the barrel diameter is given, channel width, channel height, which is 4 millimeter, width is 21 millimeter, and helix angle is 15 degrees, and the length of the screw is 1.25. So let me grab this formula. The question is calculate the RPM of the screw. or the barrel, it doesn't matter. Screw, if it is screw is fixed, barrel is rotating, or vice versa, it should have the same formula. So let me show you one thing here. Uh, the formula, yes, for the screw, yes, this formula. Let me grab this formula as well as, yeah, also write down this formula in your notebook. This formula is for the round die cube product. This, there are two formula. One is the for the rectangular die, and which you already wrote down, and one formula is for the flow or discharge through the round die. In this case, we have a round die, so we will use this formula, and this pressure drop inside the die is equal to the pressure inside the screw. So this should be equal to, this is inside the screw pressure, this is inside the delta P is inside the die. They should be the same. So if I write down the formula here, so you are asked to find out this uh, barrel velocity. This is our question. Barrel RPM. RPM is nothing but velocity times 60 or 2 pi. So what is, if you are able to find out Vz, this will be a complete answer. But for Vz, we need to find out the other variable. What is our W? The width of the channel is 21 millimeters. So can I write down in meters? Can I write down in meters 0.021? If you write down in meters, it will be 0.021 because this is 21 millimeter. So if this is my helix, this is the width, and the height of the channel is, this is the barrel, okay? The height of the channel is this much. You see my point, guys? So this is the height, and the height is smaller, which is 4 millimeter. It is between the screw and the barrel inner surface. So I would write down height is 4, so 0.004. Agreed. Now you've already found W is given, which is 21. So let me write down 0.021. Height is 0.004. Again, 0.004 cubed. This is h power 3. The viscosity eta is 10 to the power 3. So I will write down 10 to the power 3. And dp, it is not given directly, but I mentioned dp is equal to delta p inside the die, in the die. So how will you find out the delta p? Since it's a cylindrical type extruder and the die, so you will use this formula, pi r to the power 4 delta p over 8 eta l. So I will show you what is dz. Dz we already wrote down that over here. Let me write down here. Let me grab this. Yes, dz equals to dl over sine theta. What is the length of the screw? The length of the screw is, the complete length of the screw is 1.25. So I will say dz equals to 1.25 divided by sine. What is the helical angle? It is 15 degrees. Sine 15. How much is that? Is it 4.83? Please open your calculators. and let me know. I'm trying to fill in all the variables for the flow inside the screw. Yeah, you found this is correct. Okay, now what is left? I think everything is given except VZ and Q. How will you find out Q? You already know that Q equals to 1.96. Let me show you over here. I think we found this 1.96. Let me write down here. Is the same flow inside the screw. So because Q product equals to the Q screw, and Q screw equals to Q screw equals to, it has a formula, W times velocity along the helix lines, Vz time h, the height of the channel, minus height of the channel cube divided by 12 times eta, and dp over dz. So let's plug it in everything over here. 1.96 in 10 to the power negative 6. Agreed. W is 0.021. Okay. 0.0. VZ, we have to find out VZ. That is our goal. 0.004 divided by 2 minus 0.004 power 3 divided by 12 into 10 to the power 3 times dp over dz is 4.83. You just calculate it. Now, how will you find out dp? I'm going to show you from this formula. That for the round die, the discharge through the die, it is the same as discharge inside the product. It is the same as discharge coming out of the screw. Okay, so this is the fact. So die is a cylindrical die, so I'm going to use this formula: pi r to the 4 divided by 8 eta delta p over the length of the die. Length of the die is how much? You can see the length of the die is 40 millimeters. Let me write down here everything. 1.96 in 10 to the power negative 6 equals to pi. The radius is 5 millimeter is the diameter for the die. Agreed. The diameter divided by 2 is the radius, which is 2.5. So I can write down 2.5 in 10 to the power negative 3. Everything is in meters. Okay. Divided by 8 times 10 to the power 3 times delta p, which is our objective. This delta p would be plugged in over here. Okay. Make sure the steps you are understanding. The length of the die is given, which is 40 millimeters, so 0.04. So from here, if you do the math, you should get 5.1 megapascals. So from here, I found this delta P. I'm going to grab the same screw, the flow inside the screw. I'm going to grab this equation and plug it delta P over here. I'm going to plug in delta P as equal to 5.1 in 10 to the power 6 pascals. Now from here is a little lengthy, but it's not difficult. It's just algebra. Can you find out VZ? If you find VZ, you should be able to find out the RPM of the barrel. This is equal to 49.5 millimeters per second. So we know that we remember if this along the helix is VZ and this is a straight line, V barrel is rotating like tangential. So if this is rotating, it's not actually visible to you, it's in and outside the paper. So this is the velocity v barrel. Okay, and you have to draw a perpendicular here to find out vz. So vz equals to vb cosine theta, and v barrel equals to vz over cosine theta, and vz is 49.5 divided by cosine 15, which is equal to 51.2 millimeters per second. Agreed? So now once you find out the tangential velocity of the barrel, so you can tell me, Professor, this n equals to or v equals 2 pi nd. So let me write down v barrel, it is in millimeters per second, right? So if you divide by or pi dn over 60, this is equal to vb. Do you understand that? Pi d is circumference times how many revolutions divided by 60. The diameter of the barrel is how much? It is 28. The diameter of the barrel is 28 millimeter. So let's keep it in millimeter. In the numerator is millimeter, denominator. So the right answer is 35 revs per minute. Please note it down. Do you understand that question? It's little lengthy, but if you go slowly and plug in the variables which are hidden somewhere in the data, some missing in the calculation, you have to apply 3 4 equations. Mostly the q flow, q die, q flow in the screw, which is the flow in the screw equals to the die to the product. So let's do one more problem. Let me show you the answer here. When you go home, you can start. I'm going to open the problems with their solutions so that you should practice. I would not give all the solution, but at least 2 3 problems with the solution, 2 3 without solution, so that you will practice. This is going to be in your final exam. Polymer injection, the machining will be, and the bending. You remember we did not, I did, next week is the quiz, including bending and injection molding. You want me to send you the solution early possible so that you prepare for the quiz? I will do that. To make a shot, use screw extruder equation to for flow rate to produce shot volume. Q can also be written as volume of the shot divided by time, or volume of the shot equals to Q times T. It's the same thing. So Q can be written as velocity times area. This is velocity. Can volume divided by time. The back pressure gives dP, and time is bounded by cycle, upper and lower cycle. So okay. Now what happens? Injection mold a polymer in a steel tool, model the sprue runner and the part as cylinder of 10 millimeter diameter. Length is 150. How much is the length? 150. Before that was the length. It was 40 here. Now it's 150. Determine the screw RPM. Make a shot in less than 3 seconds. So also you will practice these slides, the problems given in the slides, you will practice those problems because the homeworks will be similar to these slides problems. So it's better. So I'm gonna give you extra homework problems here. So let me show you one thing here. Determine the screw speed, RPM to make the shot in less than time. Time is here, the time 3 seconds, and the volume of the shot is how much? Pi r square, pi r square times the length of the product. The volume is of the product is pi r square times the length. Pi r is how much? 5 millimeter square. The length is 150. And this is the volume, and Q equals to volume divided by time. Okay, guys. So volume is pi 5 square 150 divided by 3 is 3,927 millimeter cubes per second. Okay, so now we have to, after we find this Q inside the die, that is equal to the screw diameter, screw flow, right? What is the formula for the screw flow? The formula is written over here. This is the formula. Okay, I want to see what else is information is given. Okay, I want to see this information is given to us. So let me grab this one and plug it in over here. 39, 21. V is equals to pi d n over 60. And this barrel diameter is given. The barrel is bigger. Suppose this is our screw and this is our height. Height is on both sides of the screw. So I have to find, in order to find out the diameter of the screw. Look, suppose this is diameter of screw. So diameter of screw equals to diameter of barrel minus 2 times the height of the channel. Do you understand that? So the height of the barrel is 28 minus 2 times the height of the channel, which is 4, 20 millimeter is the screw. So I can write down this is my screw here. See, so V screw equals to pi d screw times n over 60. And Vz equals to V screw times cosine theta. I think I mentioned this earlier. Vz equals to Vb. Yeah, it's the same thing. Suppose this is our screw and rotating is Vb or V screw helical Vz. This is theta. Okay, so Vz over Vs equals to cosine theta. So can I write down Vz like this Vs? So W, I can write down Vs cosine theta times the height. How much is the height of the channel? 4. So I can write down 4 divided by 2 minus 4 cubed divided by 12 times the eta 10 to the power 3. 10 to the power 3. Now here, the length of the screw is 1.25. In order to find out dz, you remember I showed you if this is the vertical and these are the helix at an angle theta. So this is my axial length, this is my helical length. Sorry, this is my helical length along the helix line. This is my helix line. So what should be the DL? This DL is how much? Is DL or the complete length is 1.25. So let me write down DL over DZ for a small portion equals sine theta. That means L over DZ. I can write down DZ as a complete length. Okay, DZ equals to the L over sine theta. 1.25 is the barrel or the screw length. It is 1.25 in millimeters, 1250. 1250 divided by sine. What is the helix angle? It is 15 degrees. It is 15 degrees. And if you closely look at the statement, look, the statement is showing you. I think I missed one part. No, I did not miss here. Look over here. Yeah, one slide I missed in the data. No, I screw RPM. Okay, screw RPM. Yes. Look, if you closely look here, I think, yeah, did I show you this slide? No, I did not show you this slide. Yeah, I have to show you this slide. In this slide, what is given? The back pressure. If you see, the back pressure has been given rather than we calculate from the die, the back pressure in the screw, it is dp, which is 15 megapascal. So everything is complete now. This is 15 megapascal. Okay, 15 megapascal divided by dz, which is 1250 by sine 1250 divided by sine 15. Okay, agreed. Now look, everything in this equation, everything is given with one unknown. So when you go home, you try solve this. So once you know Vz from this, when you solve this question, Vz, you can find out, and Vz equals to pi dn over 60. This is our screw. So that means give n equals to 101 RPM. We will start from here next week. Okay.